If you watch a Year 8 child write their first Python program, you'll see the same thing. Type a line, run it. Change a character, run it again. Programmers call this guessing. It works for tiny problems and falls apart for anything real. The thinking step underneath has quietly gone missing. A child who types first opens the editor and pokes at it until something works. They might finish, but they don't really own the code, and they couldn't write it again tomorrow. Professor Turing works the opposite way, named after Alan Turing, who did most of his work with a pencil. The rule is one line long. No code is typed until the algorithm is drawn on paper.
Here is how a session actually runs. Take a simple task. Read 10 numbers and print the average. First, decompose it into plain English steps. Second, plan the algorithm, what to remember, what loops. Third, dry run it by hand with fake inputs, which catches the off-by-one bugs before any code exists. Only then, fourth, translate it to Python. Because it was planned, the code usually works first time.
And Turing is not on his own. He joins a growing faculty, sitting alongside Professor Pi for maths, Quill for English, Darwin, Curie, and Newton for the sciences, and more. Mentor sits at the center, coordinating them all. Every tutor shares the same Socratic habit: understand before you do, and the student always takes the last step themselves.
And whatever the subject, Mentor checks energy first. Green means push on with harder algorithms. Amber means one small problem with plenty of support. Red is homework triage, just enough to get the next thing done. Well-being comes before any worksheet. We are now inviting the first 100 founding member families. Turing won't replace a great computing teacher, and he never will. But for a child who can plan a program before they type it and own every line they write, you are warmly welcome to atutors.me.
Learn more at atutors.me.